Hello, good afternoon, Western Australia mathematics applications enthusiasts. Should I say money enthusiasts? Because tonight's session is dealing with financial applications, particularly loans and investments and annuities. This is the final session, 5 of 5, for your review series in preparation for your WACE exams. I know you only have one more school day left remaining. Enjoy that, well, for the term anyway, before your holiday break, and only a few short fleeting weeks before you launch into your exams. We certainly hope that this series has provided you some helpful hints and a bit of an advantage when you head into those exams. This topic, I know certainly one that receives a fair bit of attention in the exams. And it's a good one. It's a fairly important one, not only for your exams, but basically on your prospects in life. So it's a good one to get your head around. And so without further ado, I will head over to the star of Jodstar, Mr. Jody Crothers. How you going, Jody?
I'm doing very well, and thanks to everyone who's attending the session this evening. I look forward to going through the finance questions, the annuities, the perpetuities, and using the finance solver on the calculator, talk through the concepts, get you through, and we'll go through some exam-style questions to better prepare you for what's coming ahead. Wonderful.
Fantastic.
Would you like me to take over now?
Have a go. Ball in your court.
Excellent. I look forward to it.
Quite a few online this afternoon, Jodstar.
That's great. It's always good to see the attendance.
Yes. And
here we go. Well, let's start with what you have access to in the exam. These questions can appear in the Calc Free section, but more often than not in the Calculator section. SCARS provide you with the formula sheet, and the formula sheet will have these formulas on them, and we'll go through them as the effective annual rate of interest, and simple interest formula, and a compound interest formula, compounded annually and compounded n times a year. And we'll have a look at those when answering some of our questions. So what specifically will they examine you on? Let's have a look. SCARS syllabus talks about compound interest, loans and investment, the use of recurrence relation model to a compound interest loan, which we'll go through, or investment. Investigate numerically or graphically the effect of interest rates, which you should have done in class, and the number of compounding periods on the future value of loan or investment. We won't do too much investigation through this. We'll actually just take you through the questions, because hopefully your investigative process will have taken place in class. We'll use the calculator to calculate the effective annual rate of interest, which is the formula that was prepared before, and use the results to compare investment returns, the cost of loans, and looking off when interest is charged at different rates. Also, it talks about, with the aid of a calculator or computer-based finance software, which we can't use in the exam, so the calculator we can, to solve problems involving compound interest loans, investments, and depreciating assets. Second part talks about reducing balance loans. So something where you've got a loan and you're making a periodic payment. So it sounds pretty recursive to me. So we'll actually show you how that works.
Recursion, yeah.
So we'll take it through that way, and we'll also show how to use it with the finance solver as well. The last part, it talks about annuities and perpetuities. And I'll shortly go on and explain what the differences between those. And again, it's talking about recurrence relations for annuities, numeric or graphically, and also then talking about using a calculator to solve questions involving them. And perpetuities are a special case, and we'll talk about that shortly.
It all sounds fairly complicated, but the reality is it's not too difficult.
No,
perpetuity
it's not.
Just a special type of annuity, is it not? Yeah.
That's correct, and in 2 slides' time I'll talk about that one. So what are compound interest loans and investments? We talked about those. We have a starting amount of money. Either we've invested a start or we've borrowed it. There's an interest rate involved, normally quoted annually, but can be calculated at different rates, daily, monthly, fortnightly, depending on the situation. And there's payments for investments and repayments for the loans. So different use of language depending on what you're doing. So what's an annuity? An annuity is an investment in which you draw down from, or basically means you get a regular amount from, until it runs out. Often used by people who are looking into retirement. They've gotten their superannuation money all together, they put it into an annuity, and from there they draw down a regular amount each year until the money runs out, basically. So for financial purposes, you need to have an endpoint. My parents are dying in 2035 for financial reasons. They've already penciled that in, so they can go through and make the calculations. And by that time, there won't be anything left for me. But that's okay.
Right.
So a perpetuity. Something's perpetual, goes on forever. When they talk about perpetual motion, which is something physicists would love to find, it's something that goes on forever. So basically, in terms of what we're doing, is you have $100,000, earn $5,000 a year in interest. So you just take that $5,000 a year in interest, and you don't actually touch the capital or the principal. You just take the interest each time. So it can go on forever and ever and ever.
And that way you would get an inheritance?
Yes. Yes. But in real terms, it would devalue. So.
Oh, okay.
They can spend it while I've got it. And the other thing we're going to be looking at is a finance solver. And there's some terminology, and we'll go through it with individual questions, but I'm going to talk about it in general terms now. When the bank gives you money in a transaction, it's positive. When you give the money a bank, it's negative. So if you're making a repayment for something, it's a negative. But the bank's giving you money, so you're getting money from them, it's a positive thing. Now, the next slide.
The two different directions.
Two different directions. For a loan, the amount of money is positive. The payments you make are negative because you're giving money back to the bank. And your future value, FV, so at the end of the loan, you either want it to be zero, which is basically where you need it to be zero, or possibly negative if you're paying a little bit extra off. Now, the annuities, you're giving the money to the bank. So that's a negative, but then they pay you regularly. That's a positive. And your future value, well, you're hoping that's going to end up with zero, so they end up with no money to pay you, or they end up with a little bit of money to pay you at the end. The other one is an investment that you add to on a regular basis, so that compound interest investment we were talking about, compound interest. And that has, again, the bank has the money to start with, it's negative. Then if you're adding money to that, so you're paying more money to the bank, that's negative. So the future value, after you've made your investment and made some more repayments, the future value of that will be a positive thing. All sounds a little bit complicated. It's taken me a while to get my head around, but when we do it in the context of the question, it should make a bit more sense. And it's something that I would have on my notes page when I do the exam, for a couple of reasons. A, questions using this will generally be in the calculator section, and it's important to get them right.
Yes,
this takes us to a first question about Matt. And from here I'm going to hand over to Brian, and Brian's going to take us through this situation where Matt has just retired. He's had some good savings too.
Just short of $1 million, which is not too bad. And it looks like he's retired, with a bit of life to go, because he's expecting to get this to finance a bit more. So that's good too. So let's examine the problem. Now, this is one where it's been a huge industry of growth in the last 20 years or so. Financial advising industry. My brother actually works in this industry, and basically he makes his money out of advising people how they can invest and plan for their retirement, and then how they're going to have a shall we say, an annuity or pension payment out of their lump sum of retirement money to hopefully see them through till the end of their days, and not be dependent on a pension, because I think the rules for pension are getting harder and harder all the time. So here's a situation, and the figures here are fairly realistic, actually. A fellow called Matt, $850,000. So that's a fair bit of savings he's put away over his working life. But he's now looking to retire. Shall we say he's 60 years old, and with a life expectancy of somewhere in the 90s, we would think. And our financial people actually look at tables on this. They look at they have the records and the facts and figures of. And I know it might sound a little bit morbid, but it makes sense to work out how long are you going to live for and what's it going to cost. That's future planning. So let's work this out on the calculator. So we'll go through the story. He's basically putting this money into an investment, which he earns 5% interest. So really, that's not a bad investment these days. 5% interest per annum. And he wants to withdraw every Christmas at the end of the year. He's going to withdraw $60,000. And his pot of money is going to sit there for the first year because he's actually got enough savings at the moment to keep him going for his first year of retirement. So the problem is, after his withdrawal at the end of the 15th year, how much will be left over? It's not just a matter of taking $60,000 away from $850,000 15 times, because we've got this compounding effect of the interest as well. Quite luckily, 2 weeks ago, we did a session on number patterns and recursion, and we hinted then that the real applications of that, or very practical applications, a lot of them are in the financial world. This is a classic example. Let's just take a look how we do this just on a calculator page on your calculator. I'm going to put in the $850,000. You may recall we did something similar to this a couple of weeks ago. And if I press enter, the calculator memory now sees 850,000 in its memory. And so if I then commence by going multiply that, so on the next line, if I multiply, and see it's come up with ANS, answer. I might just make this bigger so that you can see. And the answer I'm multiplying by 1.05. If I multiplied it by 1, it would be exactly the same, no bigger, no smaller. If I multiply it by 1 and a bit, 1.05, that is 1 and 5 hundredths. See, the 5 is in the hundredths place. Think of the place value. Here are the units, here are the tenths, here are the hundredths. So 5 hundredths is 5%. So what's happening is I'm taking my previous answer and increasing it by 5%. If I were to be decreasing it by 5%, what would I be multiplying it by? See if anyone can type an answer into the chat screen if I was decreasing it by 5%. Okay, looking further to our problem, we have looked at interest here, and we're then going to, so that would be at the end of the year, and then we're going to take out our $60,000. So I'm going to subtract 60,000, and let's say this is taken out at about Christmas time. And so then what remains when I press enter, that's then the balance going into the next year. Okay, so this is at the start of the second year. And every subsequent time that I press enter, it repeats that process. It takes answer, i.e. the previous answer from the previous line, and multiplies it by 1.05, that's the interest, and then subtracts the 60,000. And I just need to count how many times, and I could count my 15 years through here to see what I end up with after 15 years, 1, 2, 3, 4, 5, etc. I think you can see that's perhaps not the most efficient way of doing it. Oops. And yeah. And yeah. And I'm just going to pop another page in. I'm a big fan of lists and spreadsheets, and so also are finance people. When Microsoft first developed their their personal computer, they actually had a little bit of difficulty trying to market it as a word processor because typists sort of had things like that under control. What really, really broke into the business world was spreadsheets, because the various bean counters looked at that and thought, wow, this is really going to speed up what we're doing. So here we are, and as we've mentioned before, the spreadsheet tends to integrate fairly seamlessly with Excel, the spreadsheet in Inspire. Now, I'm going to put a sequence in here. Remember we did sequences 2 weeks ago? So I hit Menu, Data, and I'm going to generate a sequence, and the formula will be the next value will equal, or the current value rather, UN, will equal UN minus 1, that is the previous value, multiplied by 1.05, as you saw on the other page. Remember, I've got to subtract my 60,000. And we'll make the initial term 850,000. And let's run this up to, we'll say 40 years, okay? So we're going to go, let's say our friend is retiring, Matt's retiring at the age of 60, we'll run him up to the age of 100 and see how his money goes. So that's the values in there. Press Enter, and here are the same values, you'll see, that I had in my sequence on the previous page. And if I want to see what it's going to look like after 15 years, I scroll down to 15, but remember the question was after 15 years, so that's the balance at the start of the 15th year. At the end of the 15 years, this is how much money remains. Okay, so let's go back to our question. We've answered that. And when you go to the Google Drive to take a copy of the PowerPoint, you can have some screen captures of what we've just done to help prompt your memory of this. And this one here is showing another way to do it, as Jody mentioned before, a thing called Financial Solver. And this is where we use the positive negative. This is the greatest little tool of the lot. I think for anyone who perhaps hasn't got on board with using programmable calculators, this one little feature justifies having it, in my view. If I knew I was going into an exam where I'm going to be asked questions about finance, I would absolutely love to have this. So on a calculator page, from the main menu, 8th option, Finance Solver. You don't have to worry too much about the other things in that list. Finance Solver is all we're after. And N, the number of years, is 15, and the investment. Now, see, it's got percentage here. So that means that the calculator is going to take 5. If I just type 5 rather than 0.05, it's reading it as 5%. So it will put that 5 in the hundredths place for me. And in the next one, our present value is, now remember, I'm putting this money into the bank. So that's taking it away from me. That's negative because it leaves me. So 850,000 has gone away. The payments that come back to me are 60,000. And just down here, we're looking at it compounding once a year. So payments to me are once a year, and the compound is once a year. So the future value, I click in that part of the window and just press Enter on the calculator. And so here's the future value. So what I've got, $472,375.14, which is pretty much what I had down here. Okay? So the Tvm Solver, absolutely the best. So you've seen the same thing done 3 different ways there. Extending the problem. Do you want me to continue with this, Jodstar? At this rate, after 25 years, he'll only have this much left. Let's have a bit of a look. So what have I got? 14,000, or just under 15,000 after 25 years. So that would not be enough to finance the next year. So here we are after 25 years, we've got this much. So at the start of the 26th year, and then it's gone negative, which means there's not enough money to keep the show going. The question asks, if he wants it to last for 35 years into retirement, how much should he be withdrawing? So we need to change something. We need to model this. And at the moment, he's taking out, remember it was 60,000 a year. He probably doesn't have a lot of power over what interest rates are going to be paid. So maybe we're going to have to change that 60,000. So what we'll do is we'll put over here, withdraw, and the amount we're going to withdraw is, well, let's go with, instead of 60,000, let's go with 30,000. Could we tighten our belt and live on that instead? And so at this time I'm going to do the sequence. So it's U n minus 1. Oops. Multiplied by 1.05. Remember how that works. That's our 5% interest. And I'm going to subtract, and I'm going to be sneaky here. Did you see that cell? I can't move that completely out of the way, but it's in column D2. So I'm going to put D2, or in cell D2. So what it will do is it will go to that cell reference, D2. Okay? Once again, our initial amount was 850,000. And we'll set it up for, once again, 40 years and just see what it looks like. And let's go. And something, it was in C2. I said D2. It's in C2. I have to change that. I can go back in here, and the beauty is I can edit things here. And yes, I will overwrite all that. Nothing. And there we go. So there's our money going down. And so I can go down here. What am I looking for after 35 years? And you can see there's a fairly laborious way of doing things. But what's happening is after, where are we? I've kind of run out of money here. It's going into a different, it's going to this E6, so it's multiplying it out for me. What have I done? It's going up, John Star. I've done something crazy with my sequence, haven't I? By 1.05 minus C2. I'm just going to have a quick look at what's going on here. Jody, your microphone went muted there. I'll fix that up.
Okay. Yeah, you may not be taking out enough money.
30,000.
Yep. So take it back up to what you had before, which was 60,000.
Yeah. So okay. So let's go with this. We'll go with 60,000. And
just 60,000 will tell you if you're getting exactly the same numbers as you're getting before.
Yep.
Which you are.
So that's what's happening. Yep.
So if you only take out 30,000, you make a profit.
That's right. I'm making too much money. That's it. Yep. So what's the amount we want? What's the magic number? I guess is what we're looking for. So it's a trial and error thing. So what's go for 50,000? Okay. How am I doing after 35 years? So you can see how this is working. So 35 years. Yeah, I'm still looking good. Can I go with more than 50,000? Can I go with 55? Can I go with 58? And so on. I can keep trying that. And as we've got on the PowerPoint here, there's a couple of ways of doing this. 52,000. This is a hard way of doing it because it's operating by trial and error. Come back to our Tvm Solver an easy way is to just put the values in that. So let's have a look at that. Tvm Solver. Need to be on a calculator page for the Tvm Solver to work. And we're wanting 35 years, interest rate at 5%. There's our money. I want to know what the payments are. And the future value for a lot of these ones, students, remember, future values, if you're exhausting something, like if you're exhausting an annuity or you're paying out a loan, the future value will be zero. Okay? So I want to know the payments. So I'll press enter in here. And it's saying it just under $52,000. So $51,911, about that. $51,911. And if we come down to our 35 years, so there's our 35 years, and then in the 36th year we've run out of money, or just at the end of the 35 years we've run out of money. So that's doing it two different ways there. One by trial and error, and you see the recursion and the sequence, and one by using the financial solver. The other way to do it, which I've set up, is there is a magic formula behind all this, and I've put this in here. There is a thing called an Annuity Formula, which you don't really need to use for your course, but here it is here. I've run the figures into a formula and got the same value, and I also set up a page here with the notes and spreadsheets, which does the same thing. This here is the formula. So I'm aware that that's not in your course, but I just thought I'd give you a sneak preview of the mechanics behind what's going on, because I dare say that at some stage there was a guy in Texas or a girl in Texas who knew that formula when they programmed this into the calculator. Don't you reckon, Jody?
I think, yeah, that's exactly right. And it's really useful to have a look behind it. For the purpose of the exam, I wouldn't go learning the new formula, but that TNS file will probably be in the Google Drive with that formula. If you want to pick it up and run with it, that would be great. Yep. Wonderful.
Actually, I do remember, and it was pretty much at the end of my Year 12 year, a financial advisor coming to visit. It was a mate of my father's. He came to visit us at home, and he was trying to sell me some investment scheme, and I looked at his numbers, and I was able to work his formulas backwards, and I actually came out with the interest rate. And I said, no, mate, I don't think it's that particularly good. So it is handy to know how some of these formulas and things work, so that you can be in a little bit of control of your own finances.
Wonderful.
Of course, I didn't have calculators and computers to help me at that stage.
Oh, that's scary.
Effective interest rate. That's a really interesting thing.
Yep, and that's the start of the exam type question I'm going to be dealing with today.
Yeah.
Now, the effective interest rate formula is actually provided, if we can remember, I'll take it back there quickly.
That is on the formula sheet.
It is on the formula sheet. And in this particular question, they're providing you with the formula in the question as well to have a look at.
Uh-huh.
So I'm actually going to start a new document and take people on a notes page and take you through how to create this formula and use it. So here's one that I would actually have ready to go. So I'd have an effective rate of interest. I'll put some spaces in there too.
So just a heading for the page. That's just text. It does nothing. Yep. Math box, yep.
And then I'm going to go ERI. That's where we're going to define the formula. Colon equals, so that's the definition. And then we're going to go through and enter the formula. So bracket 1 plus. Use a template for the fraction. I'm going to use I and N. That'll be across there to the power of N and then we're going to take 1. So that's the formula. So we've defined the formula, we put it in there. And that's going to rewrite the formula. It looks slightly different. It likes having all this one fraction inside, but there we have it. Nice to look at, not particularly useful at the moment. So what we're going to do is we're going to define the variables, the interest rate and the number of compounding periods in the year. So interest rate we've put I, column equals, we're going to do 5%. In this case we go 0.05, that's 5%. Hit enter. As you can see, the effective interest rate formula changes there, but it still has an end value. So we're going to have define what our end value is. In this case, we're going to do 52 times a year. So 5% done 52 times a year is effectively 0.51246. Now we can go back and change any of these values. If I want to do it daily in a non-leap year, there we've got it. And we can go through and do this. Now let's have a look at the question. In this question, calculate the interest rate per annum if the effective interest rate is 4.06 when the interest is compounded quarterly. So this little spreadsheet's not going to work for it, or this little notes page isn't going to work for us at the moment, but the formula will be useful. So I'm going to insert a new problem, and the reason I'm using a new problem is I'd like to use some of the same variables. I'm going to go back and steal this, copy.
Gotta love the cut and paste.
Paste that in there. I'll hit enter, and that doesn't do anything for us, which is okay. What we're trying to do, in this case, we're trying to solve a question. We're going to try and solve, we know the effective interest rate, which is 4.06, is equal to brackets 1 plus, use the template again. We want to find out what I is. We want to find out what I is, given it's compounded quarterly, which is 4 times. So that's the power of 4.
And we'll have to solve for I.
Take 1, and we have to solve, in this case, for I. And let's make sure that's a comma there. And that's telling us I is, but something's not quite right.
We get two results.
Well, we've made a mistake here in terms of I've put the interest rate in as a whole number. So that's actually 400% interest. So what we need to make sure, and that's what's different to the finance solver, it's 0.04.
This is, yep.
And now this will give us a more realistic interest rate. So this interest rate is minus 804%, which is really useful, or 3.999996%. Now, because it's to the power of 4, it means we've got the possibility of having 2 answers, a positive and a negative one. Looking at it logically, we can discount the minus 8, because I'm not quite sure how that interest rate would work. I think they'd be paying us money.
They'd be stealing your money, yep.
Or in this case, the 0.03999996 is pretty close to where we need to be. So that's it. So it's 3.999996%.
I'm going to call that 4%.
I would too, remembering they've given us everything into 2 decimal places here. So let's give them an answer to the corresponding accuracy of 2 decimal places. So we're settling on 4.00% interest. So which becomes effectively 4.06 when it's compounded quarterly. So there's our answer.
Yeah.
Let's go to the next part of this question. We've got young Peggy here. Is investing $40,000 at 6.8% per annum compounded weekly. Her friend Tom has the same amount of money compounded daily. Calculate the daily investments after 1 year. who has the best investment, and by how much after 1 year. We have a compound interest formula given to us on the formula sheet. I would be setting up a notes page as I have here, putting the formula into a notes page ready to go. So we've got the amount, principal, rate, number of compounding periods, number of years. So we've got this information. So we've got 40,000 compounded weekly in this case, first case, which is 52 for 1 year, at an interest rate of 6.5.
This is like your very own little Tvm solver.
That's correct. But I find it's a lot nicer to be able to play with the variables and have a look.
Yep.
Here's our amount. So this is what I'd be writing down. I'd be writing that's the amount that Peggy has after 1 year. The amount Tom has after 1 year, and I'm actually going to copy that. Control I, create a little calculator page. I'm going to paste that there. So I've got it for later.
Yeah. Reference.
So, and now I've got Tom. Tom's got $40,000 as well. But he's got an account which is daily. I'm going to assume this year it's 365. Actually, let's do 366. It's a leap year.
Okay.
Most of the time it'll be 365.
Yeah. Probably about 3/4 of the time.
Yeah, on average. For 1 year. And his interest rate is 6.3. So lower interest rate, but compounded more times. And this is how much Tom ends up with. Copy that one. We've got Peggy's. We've got Tom's. Looks like Peggy gets more. How much more? $83.80.
And that's even in a leap year.
Yes. Oh, man. I'd be going with Peggy's investment.
I think
it's important. So. Even though compounding daily is helpful, it's not going to make up that 0.2% interest rate difference. So Peggy has the best interest, our best investment. We've said it's by $83.80 after 1 year. So we've gone through, we've calculated, we've shown the amounts each has invested. We've stated that Peggy has the best investment. We've stated by how much. We've answered the question. And that's a really important thing to go through and do.
Jody, I have heard it said, and I don't know if it's correct or not, but a quote that Albert Einstein, for all of his work in physics and the forces of nature, when talking about compound interest, said that there's nothing more powerful in the universe than compound interest, just given enough time.
But Einstein also said, time, said Einstein, is something measured by a clock.
Yes.
Because short of days, all the time things are man-made constructs. And we could get into the ancient Sumerians and Hittites and 60, but we won't today. That's a whole different discussion. But it's a really interesting one for people who want to pursue it.
A little bit of special relativity, yeah.
Okay, the next question. This is one you'll see in an exam more often than not. Rather than have to do with the calculations, they're going to have values in a table, and you're going to have to fill in the missing value. So in this case, we've got Jimmy with $300,000 at 5.25% per annum, compounded monthly. He withdrew $4,000 each month for living expenses after the interest is paid. Consider the table below. We've got to find the values of P, Q, and R. So we have our opening balance, we add the interest, we take away the payment, that gives us the balance. That's good. So we can work our way backwards. P here, we're going to have to calculate. Once we've calculated P, Q will happen easily. And Q can happen easily too, just by working backwards for the line 2. And 3, R is going to be easy to do too. R is just going to be simply 294 3.24. Don't feel that you have to work these things out in order, plus the interest. Because
it's a very typical type exam question, isn't it?
Yes.
Yeah.
So we've got our value for R straight away. If we want to have a look at our Q, we can solve for Q. Q plus 1300.74. So that's the opening balance plus that amount. Take away 4,000 equals 294,613.24. We want to solve that for Q. Bang, we've got a value for Q.
Bang. Easy way to do it, yeah. Now,
the interest, we can actually calculate the interest. We can go, I'll do it two ways. A straightforward way is to go a $300,000 starting point multiplied by, make a little fraction because I like the fractions, 0.0525, that percent interest, which is nice. We want a 12th of that because it's a month, and that gives us that value there. The other way we can do it is we know what Q is already, so we know that we can solve, open our brackets, 300,000 plus T, which we don't know. We use it. Let's go inti, which we don't know. Take away 4,000 is equal to 297,313, and we want to solve that for inti, and there we have it, 1313, 13125, and they rounded to the nearest dollar. So you can actually do that, the first part of the question, without actually having to do interest rate formulas or multiplication. You can do it simply on addition and subtraction, if that's the way you want to go.
Yep. I think it's important for students to know what's going on with that type of table.
That's right.
What's actually happening with the money. Try to think about the actual situation.
So, and the reason I'll do it this way is they figure people are going to have things programmed in their calculator. You can't have that table programmed in your calculator because you don't know all the parts.
Mm-hmm.
So you can work it through, and as you go through, you can see what's happening. Now, how much is left in the investment at the start of the second year? Good, the start of the second year is the balance at the end of 12 months. We could go through and use that table. That sounds like a lot of work. We could go through and create our own formula. That sounds like a lot of work. I would actually go and use our finance solver.
Yeah.
Opening balance minus 300,000. Interest rate.
You should put that into the bank.
Yes. Interest rate. Interest rate in this one is done straight as percentage, so we don't have to do anything to that. Wait a sec.
Yeah, the thing to note there is because it's got
let's go back and put the numbers in the right spot. It doesn't like us. Menu. I got overly excited with all that money. We'll leave the number of periods clear. Now we'll put our 5.25.
Present value. Yes.
Now our present value is minus 300,000. Otherwise we're going money back into the Stone Ages, and that's fine. Now the payment. The payment is 4,000. The payment is positive because the money's coming to us.
Yes.
And we want to know after 12 what the future value is. And we go, enter. Whoa, How's that looking?
Now, are we looking at 12?
But that's 12 years.
12 years.
We wanted 12 months.
Yes,
so we've got to go down here and do 12.
Yep. And
now let's try it. There's our amount. So important to have a look through the whole formula. We've got our interest rate. We've got our present value, negative, because the bank's got the money. We've got the money coming to us, positive. We're looking for the future value. It's monthly, it's happening, compounded monthly. Payments monthly, compounded monthly. So that gives us our figure here.
Terms.
So that's how much we have at the start of the second year. Let's have a look at the third part. At the beginning of the fourth year, Jimmy adds $100,000 to the investment. How much longer did the account last having the extra $100,000? Okay. Well, that's got multiple parts to it. So let's go... Let's first find out how much...
for students to write their progressive answers as they go, because if they do take a value from one part that's incorrect, but then use that value in the next part, then obviously that next part will be incorrect as a result of that, but they may attract some consequential marks.
Yeah.
If there's
so what we want to do, we want to know how long this is going to run. How long is it going to go till we run out of money? Given 300,000 we're starting with. And it's going to take 91. So that's 91 is what I would copy. I would write it down, 91. I've got it written on a piece of paper just by my side here. So I can go escape here.
Yep. So remember, that's 91 months.
91 months. So we'll go calculator, 91. And then I'll go back, menu, Finance Solver. And as you know, our values are still there, which is really useful. So you can drop in and out of the Finance Solver. So it's telling us at the beginning of the fourth year, 100,000 is added. Okay, so the beginning of the fourth year is after 36 payments. That's the beginning of the fourth year. After the beginning of the fourth year, how much do we have? We've got $195,000. Jimmy's going to add another 100,000. So at this point, we've got negative, because Jimmy's adding money, giving it to the bank, $295,462 in the account.
So we've taken the balance and then we've added 100 onto it.
That's correct.
Yep.
And now we want to find out how long that would last. So we knew when we did it before...
Future value will be 0 when it runs out. Yep.
Yes, so we had it before and we knew how many months it was. 91 we wrote down. Now it's going to be 89.
Mm-hmm.
And that's 89 months added on to the 36 we had.
After the 36, yep.
After the 36, and that's important to remember.
Yep.
So we get out of that. So we had 36, then we added on another 89. So Jimmy's investment with the 100,000 added after 3 years lasts 125 months, whereas previously it was only going to last 91 months. Let's read the question again. At the beginning, money added. How much longer did the account last? Well, the account was going to be 91, now 125. 125 take away 91. It lasted an extra
almost another 3 years.
Months.
Yep.
So the answer would be an extra 34 months. And then we have the answer to that question.
Terrific.
So we have to go through, use the Finance Solver, take those values, put them in the calculator page, or maybe even write them down by hand in the test situation. So you've got them, and we've been able to combine them together to be able to solve that. So do we have any questions, Brian, from the audience? Been able to answer them as we've gone along?
I've answered. There's been a couple, and I've answered them as we've gone. Just some questions about the use of the Tvm Solver to clarify that, which is very good. And of course, a reminder that that this session will also be available for download through the YouTube link that you get, so you can replay that. And there's been a few demonstrations of the TVM Solver in this afternoon session, and so we hope that's been very helpful to you.
And I would actually remember to put this slide. I put this slide up deliberately so you can have some of those things listed in your notes page, so you know what to use. And look for the opportunities to embed some of the formulas into your notes pages so that they're to use as you need them. I wish you all the best in your upcoming school-based exams, and then finally the external WACE exams. I hope these sessions have been of real value to you and that you're able to use your calculator more effectively in this situation. Remember, you can go over these things as revision via the YouTube channel, and you also recommend it to your friends so they can go through. Thanks very much for your time and coming along and listening to these sessions. It's most appreciated. And thanks, Brian, for all your assistance in running these webinars.
Terrific. Thank you very much, John Starr. I think you've done an excellent job over the 5 sessions for this, and on Hayley as well, who kicked us off in session 1. I know I've certainly appreciated it, and I've been directing some of this to my daughter, who's studying for her Year 12 exams as well. Hers are in the Victorian exams, but of course they're both reflecting Australian curriculum. So very, very useful information. Jody, I think you've created an absolutely excellent resource there for students and teachers alike, really. And just talking for the teachers there as well, just a reminder that teachers, you can access webinars as well, not just this one here. This is the TI page, Australia. So the site here, Australia, New Zealand. If you Google Texas Instruments Australia, this is the page you get. This link here is to the Inspired Squad, where you will find the links if you want to look at them later on. There's a set for Victoria, as you can see, for exam readiness, and the other set here. So these are the webinars that we've just run over the last month and a bit. So maths applications and maths methods, and also links through to the downloadable files. So that's worth looking at. But for the teachers that may be watching, if you just click on webinars here, a reminder that this takes you to professional development webinars for teachers. These ones are coming up in the near future on 5th of October, 26th of October, and so on. So you see here some preparation for International Baccalaureate exams, and all of them are held in an archive for on-demand, where you can download associated documents and you can play the webinar as well from that time. On the actually, if we change, so I'll just go back to this. If we change this to the American site, something exciting that is coming up. It's in the pipeline. I'll just show you. Oops, I hit the wrong one there. I've gone to Australia again. Some students have been asking us a little bit about coding, looking at the power of the calculator for basically programming things, and they've asked us about coding. Coming up, coming down the pipeline is this thing here called Innovator and Launchpad, where there's a little magic box here where we can plug in lights and buzzers and motors and also sensors, and we can program it from the calculator. Don't do this before your exams, because the programming stuff is extremely addictive, and if you start, you won't want to stop. So after your exams, that's something that you can still use your calculator for, to do a little bit of coding. There is some reference to coding on our website, but also on the American one there, and these devices will be available at the Western Australian I've got the WACE conference. At the MAWA. I hit the wrong way. If I go to the MAWA conference, and for teachers that may be tuning in, can I just give this one a bit of a plug? If you go to the, if you're attending this conference in Fremantle in November, Jody will be there, and he'll be going through some of these activities. as also I will be. So I'm looking forward to that too. So that's coming up in later November. So I'll give that one a plug there. Moving forward, 21st and 22nd of November, secondary convention in Fremantle. So thank you once again, Jody. Thank you, students, and any teachers also for tuning in. It's been terrific to have you on board for this, the first year that we've trialled directing webinars to students as well as just teachers. And I think it's just been an absolutely great success with what we've developed here. I will shut the show down now and wish you all the best.